example 2. There are 3 examples we are going to do. Okay, you are going to be given a basic function from section 3.4. So what we're going to do is plot that graph based on our knowledge from section 3.4. And then you're going to be given a second function that is a transformation of that original basic graph. Okay, so we're going to apply the rules we just learned for vertical and horizontal shifts to graph the transformed function. Okay, none of this will involve making a table of values. Okay, so let's read the directions in example 2. It says, describe how to transform the graph of f into the graph of g. Then graph both functions on the same grid. Okay, so let's take a look at part A. The original basic function is f of x is equal to x cubed, and then the transformed function is g of x is equal to x cubed minus 2. All right, we are going to begin by graphing the basic function f of x is equal to x cubed. This is something we learned about in section 3.4. So remember, I told you to memorize or be able to recreate the table to know specific points on this graph, and you have to know the specific points because in order to create the transform function, you are going to shift those specific points that you know that are on x cubed. Okay, so if you recall, x cubed goes through the point -2, -8. It goes through -1, -1. It goes through the origin. It goes through the point 1, 1. And then it also goes through 2, 8. Okay, those are the key points that fit on this grid. Okay, so if you connect the dots, it has that long S shape. Okay, so it looks like this. Okay, it goes up in this direction forever and then down in this direction forever. Okay, so this is the original function f of x is equal to x cubed. Okay, so what we're going to do now is try to create the transform function. Okay, g of x is x cubed minus 2. Okay, so look what's going on here. We have the original basic function and we're subtracting 2 and there's no parentheses. Okay, so this is a vertical shift. Since we are subtracting, we are going down. Okay, so we are going to shift x cubed down 2 units to get the graph of g of x. And that's it. Okay, so we're going to go to each of the key points. We have 5 key points. Okay, and we're going to shift down. Okay, so -2, -8 is going to go down to -2, -10. Okay, and then -1 is going to shift down 2 units. It's going to end up at -1, -3. Okay, the point at the origin is going to go down 2 units. It will end up at 0, -2. The point at 1, 1 will go down 1, 2 units. Okay, it will end up at 1, -1. And then lastly, the point at 2, 8 will go down 1, 2 units. It will end up at 2, 6. Okay, so we connect the dots with the same basic shape as the original graph. That's key. Okay, here is your transformed graph. Okay, and that's it. All right, so this is g of x, which is equal to x cubed minus 2. Okay, done. Moving on to the next one. All right, in part B, the original basic function is f of x is equal to the square root of x. The transformed graph is the square root of x plus 4. Okay, so we will start in black. I will put the original graph. Okay, again, you learned this in section 3.4. You've got to know the key points on the graph of the square root of x. Okay, if you remember, that's 0, 0, 1, 1, 4, 2, and 9, 3. Okay, the square root function starts at the origin and it just goes off in this direction to the right forever. Okay, so this is the original function. Okay, we have to use this to graph g of x is equal to the square root of x plus 4. Okay, now think about this for a second. I want you to take a minute before I work this out. Okay, I want you to venture a guess as to how you think this thing gets transformed. Okay, so I don't know. I told you it's either going to be up or down. We're dealing with vertical shifts right now, or sorry, it's either going to be up or down or left or right. We're dealing with vertical and horizontal shifts. The question is, which one is it? Is it vertical or is it horizontal? And which way does it go? All right, so let's think about this, okay? What's going on here, okay? There aren't any parentheses, okay? So you're probably thinking, okay, we're going to go up 4, okay? But in actuality, this is a horizontal shift, okay? Here is why, okay? Yes, there are no parentheses here, okay? But I want you to think about what parentheses do, okay? If you have a quantity in parentheses, like if I had x plus 4 quantity squared, okay? If you have a quantity inside of parentheses, it traps that quantity, okay? That quantity is stuck in the parentheses, okay? The same thing is going on here. Even though we don't have parentheses, the square root acts like parentheses. That quantity x plus 4 is trapped inside of the square root, okay? So even though you don't physically see parentheses, the square root is acting like parentheses, okay? It is trapping the quantity, okay, inside the square root. So you can think of the x plus 4 as being trapped or as being in parentheses. So this is going to be a horizontal shift, okay? Since we're adding inside the square root or adding inside the parentheses, however you want to think of it, it is a shift to the left, okay? So what we're going to do here is we are going to shift the square root function, okay, 4 units to the left to get g of x, okay? So here we go. We're going to take each key point and just move it 4 units to the left. Okay, so the point at the origin will shift 4 units to the left. So 1, 2, 3, 4. It will end up at negative 4, 0. The point at 1, 1 will go over 1, 2, 3, 4. Okay, it'll end up at negative 3, 1. The point at 4, 2 will go over 1, 2, 3, 4. It will end up at 0, 2. And then lastly, the point at 9, 3 will go over 1, 2, 3, 4. It will end up at 5, 4. Okay, you're going to connect it with the same basic shape. Okay, so this is the graph of g of x is equal to the square root of x plus 4. Okay, so I'm going to make some notes here. Okay, so I want to say here, there are no parentheses, but the square root acts like parentheses. It traps the x plus 4. Okay, so that's why this is a horizontal shift. Okay, now think about this. Okay, what would the equation have looked like if this were instead a vertical shift? Okay, here we go. This is what it would look like. Okay, let me rewrite that. Okay, so basically I had this over here because I was just trying to show you, parentheses and square root, they both trap, they act alike. Okay, if this were a vertical shift, this is what the equation would look like. Okay, I'll call it h of x. Okay, you would be adding outside of the parentheses or adding outside of the square root. Okay, so h of x would be the square root function, and then you add outside of the parentheses or add outside of the square root. Okay, so this would be the original function, the black graph. This would be the square root of x shifted up 4 units. Okay, because remember, if you add outside of parentheses or add outside of the trap, you go up that many units. Okay, I'm going to go ahead and graph that. Okay, so you would go back to the black basic graph, the original graph. You would take each point, move it up 4 units. Okay, so you would take the origin and go up 4 units. So you would end up at 0, 4. You would take the point at 1, 1, go up 4 units. You would end up at 1, 5. You would take the point at 4, 2 and go up 1, 2, 3, 4. Okay, you would end up at 4, 6. And then lastly, take the point at 9, 3, and you would go up 1, 2, 3, 4. You would end up right here. Okay, so actually, let me get rid of this g of x business here. I'll rewrite it. Okay, I just want to make sure you understand the difference. So let me recreate this last point. 9, 3 would go up 1, 2, 3, 4, ending up at 9, 7. Okay, so here would be h of x. Okay, so let me label this. This is h of x is equal to the square root of x plus 4. Okay, and then this is g of x, which is the square root of x plus 4. Okay, make sure you understand the difference. Okay, you will see this again and again. The square root acts like a trap. It acts like parentheses. Okay, going forward, another thing that acts like parentheses is going to be the absolute value symbols. Okay, they are going to trap the quantity inside. So if you're working with absolute value symbols, you're going to treat them like parentheses as well. Okay, all right, speaking of absolute value, okay, that brings us to part C. Okay, the original function is going to be the absolute value of x. The transformed function is going to be g of x is equal to the absolute value of x minus 1 plus 3. Okay, so we are going to start out. Let's start by graphing the original basic function here, which is f of x is equal to the absolute value of x. Remember, absolute value of x is the V shape. It goes through 0, 0, 1, 1, 2, 2, 3, 3, and so on. And then on the other side, negative 1, 1, negative 2, 2, negative 3, 3, and so on. Okay, so let me connect the dots here. Okay, remember at the origin, you have to have a sharp corner. It has to be a V. We don't want to round it out right here. Okay, so we're going to do this and we're going to do this. Okay, the graph does continue in this direction forever. Okay, so let's go ahead and do something like this, as well as I should have had it continue in this direction forever as well. So let me just put an extra line on here. All right, so here's the original function. This is f of x is equal to the absolute value of x. So let's look at the transformed function here. Okay, so it's g of x, like I said, absolute value of x minus 1, that quantity, plus 3. Okay, we see two numbers here. You see a minus 1 and then a plus 3. So there's actually two transformations going on here. Okay, so we need to figure out which one, what they are. Okay, so when there are multiple transformations, you should follow the order of operations. Okay, what I was telling you in part B, square root and absolute value act like parentheses. Okay, so when you look at this quantity x minus 1 inside the absolute value symbols, you can think of the absolute values as being parentheses. They are trapping that quantity x minus 1. Okay, so we remember PEMDAS. Okay, so please excuse my dear Aunt Sally. Okay, when you're dealing with transformations, you definitely are going to deal with, these, you could see these things. So parentheses always comes first. So here you're going to do the transformation that involves the x minus 1 being trapped in absolute value symbols first. And then because you're adding 3 outside of the absolute value symbols, that's addition. Eventually you will do that. Okay, so we're going to do the minus 1 first, and then we will handle the plus 3 after. Okay, all right, so let's talk about the absolute value of x minus 1. Okay, what does that do? Again, the absolute value symbols are acting like parentheses here. So think about if you had x minus 1 in parentheses. Okay, that's going to be a horizontal shift, and since we're subtracting inside, it is going to be a shift to the right. Okay, so we're going to shift write 1 unit. Okay, so we're going to do that first. Okay, and then you have the plus 3. Okay, the plus 3 is not inside parentheses, not inside the absolute value. Okay, it's on the outside, so that is a vertical shift. And so since we are adding, that means we're going to go up by that many units. Okay, so the plus 3, that's going to make us go up 3 units. Okay, so what we're going to do is we're going to take each point on the absolute value graph and we are going to shift it right 1 unit and then up 3 units. Okay, so I'm going to write that here. So to get g of x, take each point on the absolute value graph and shift it, right 1 unit. So right 1, then up 3. Okay, that will give you your new transformed graph. Okay, so let's start with the point at the origin. Okay, I'm going to shift it right 1 and then up 1, 2, 3. Okay, that's going to send us to the point 1, 3. And then, I just start moving points. So if I go back to the black graph, take the point at 1, 1, we're going to shift right 1 unit and then up 3. Okay, that's going to bring us to 2, 4. And then take the point at 2, 2. And then shift it right 1, up 3. Okay, and you just continue doing this to all the points on the black graph. Okay, if you come over to the point at negative 1, 1, for example, you would go right 1, up 3. Okay, so you're going to end up at 0, 4. Okay, so if you transform all these points, okay, it's going to look something like this. Okay, it is going to have the same basic shape. Your black graph has just been shifted. It's been moved right 1 and up 3. Okay, so here will come the final graph. Okay, it's going to look like this. We just connect the dots with the same basic shape. Make sure this guy has a sharp corner at the point 1, 3. Okay, and then let me extend it this way, and then that will be it. Okay, so make sure you put arrowheads on the end. It's going to go up forever in this direction. And then let me extend it this way as well. Okay, so here we go. There we go. Same basic shape. So this red one, this is going to be g of x. That is the absolute value of x minus 1 plus 3. Okay, we're done. One more thing I want to mention about this particular example. Okay, once you get a lot of practice with transformations, you may be given just the transform function. So like maybe the problem will give you g of x is equal to the absolute value of x minus 1, that quantity plus 3. They may not give you the original basic function. Okay, you may have to look at this and say, look at the equation and say, hey, it involves absolute value. So the original basic function I need to work with is the absolute value function. Okay, you're going to have to recognize the basic function on your own. Okay, it won't always be like this. Okay, so you just got to, keep that in mind. It's basically whatever you see in the equation. Okay, here it was absolute value symbols, so the basic function is going to be the absolute value of x. Okay, if you went up to part B and you were given the square root of x plus 4, it involves a square root function, so the basic function is going to be the square root of x. Okay, so it's not terribly difficult to recognize, but just keep in mind you won't always be told what the basic function is. You're going to have to recognize it from the equation.